Hello everyone. Now I would like to comment on the Lab4's assignment 1. So let's check the requirements. So the assignment 1 is a high-dimensional visualization of economic data. So we have a file called prices and earnings. So let's check the data file. You can see this one, this data have the header. Okay. But it but it have a lot of space here inside, so maybe we need to process that before we doing this. So the first of all, let's check the requirement for the first question. We import this data into R and only keep those 1, 2 to 19 columns, and use the first column as a label in the future analysis. So first of all, we input the data just like this, because they have header. So yeah, we using the header equals true, and then we filter data using this, and then set the row name to the data.city and remove the data .city, $city, which means this one will disappear, and then convert this one to the matrix. Okay, so I agree with this one, no problem I think. Then the second one is plot a heat map of the data without doing any reordering. So, and then try to answer, is it possible to see cluster or outliers? So because we already have the data, so we scale the data. Then we use the plot array and plot all the things, just like this, and no problem I think. But okay, because all the remaining heat map are plotted in the red and yellow color, so it's better to change the color to to the same color, just like here. Let's check. And yes, and also I mentioned that because this one have special letters, and in iPhone 4S there's a space here, so it's better to change that, like underbar or kind of things, to convert that to a new string, not using original string, because they will have issues. So because it's the R will try to convert this data using dots, but sometimes it's not proper, so it's better to handle manually, just like this. So then we check the color too. So it's better to using the color map equals yellow and red instead of doing it automatically. Okay, then from here in the heat map we do not find any cluster, and it's difficult to find outliers, because from the plot we can see all the colors seems randomly, and it's hard to find the clusters. So next requirement is 3. Compute the distance matrix by Euclidean distance, and okay. So we try to calculate the distance first. So we try to calculate the distance of the scale data. Okay, then column list. We transpose this scale data and then do the same thing again. Then serialize using row list, using OLO methods. This one do the same. And then get order to reorder them, then make a new data structure which called reorder mat. Then we can plot this, create a new heat map. But here this also using the yellow and red. Yeah, so this is good. Okay, then here do the same, but the distance using called 1 minus correlation. Okay, all the things are the same, except for the first 2 lines. And then for both cases, compute order and optimize Hamilton path length and using HC as optimal algorithms. Then plot heat maps and state which plots seem to be easier to analyze and why. So we from these 2 plots, it's very subjective and depend on different people. So in my understanding, it's they have one cluster here, one cluster maybe here, and maybe something here, maybe at least 3. And from here we can see here and here, but we still find something very weird things here, and maybe one thing here. So the author's comment is plot both of graphs. We can see both seams have formed a cluster and in the diagonal of the heat map. Yes, we can see that one here, one here. Very clear. It seems a bit easier to analyze the heat map with Euclidean plot because there are more clusters. Okay, which means this one. But it's hard to say. But yeah, may because it's very subjective. Okay, and in case of 1 minus correlation, we can see that observation is relatively close to each other. Okay, here. But here also writes that relatively close to each other, like City Milan and Paris with respect to the bread.kg.in.min, which is here. So Milan here and Paris here. That means 2 things here, but we cannot see. So he mentioned that observations are relatively close to each other. I don't know why he said this, because for other cities maybe they like here, like Rome and Barcelona here, they almost share the same color. So I'm not sure why he said this. So the part 4, then compute the permutation that optimize the Hamilton path length by using a TSP as solver. Okay, then we try to do the same thing again, but here we try to change the parameter from OLO to TSP. And keep all the things the same, but yes, maybe we need to change the title. Okay, we found the same thing, almost same thing. This one I think is a TSP. And then he print the value of path length, gradient row in the path length, and we can see the print has a length better than TSP order. So in my point of view, I think this conclusion is not proper, or at least too short. Okay, my analysis based on this. Okay, we found that TSP TSP tried to find the shortest path length, and compared to the resultant path length below, we found that TSP will always find a shorter path than HC in all cases. That means, okay, let's check the data, TSP, but it's okay. Let's check what they write. We change the method to TSP and call the same function, yes, as what we did here, and we found the order of city name and the variable will change, which means TSP will change, this picture will change. But it will try to find the shortest path. HC focus on grouping similar elements in the cluster using tree-like structure. So we know that from here, what that provided, we know that a gradient row cannot be used to compare the performance of TSP and HC, which is even if because path length can only be used as a TSP, but not for HC. But gradient rows still have some conflict between each other, so it's still not a proper value to show which one is better. So let's see the 5. Use a plot rate to create a parallel coordinate plot from unsorted data and try to terminate the variable in the plot manually, and then to choose better cluster picture. So here, so first of all, we need to do this. We get a scale data, and then we need to make a dimension list. We can do it like this, and we also can do like this. This is almost similar, my implementation. Okay, but we can using the value or using the things like this kind of index. Okay, then we can see from here, this is original one, and we can find, okay, we can try to figure out the cluster here. We can find the cluster like this. So we then try to find, yes, maybe we draw a conclusion here. We've set a filter here, maybe a set a filter here, maybe a set a filter here or something. Yeah. Okay, so then we will get things like this. So we can see the plot that there is a cluster with iPhone, Big Mac, Rice, and KG in case Big Mac. There are 2 clusters for value greater than 0 and for less than 0. So I think I only can see one cluster, but another one it's not very clear. Maybe but I think the data is not large enough, so I don't think there's a 2 cluster, but yes, just 1 cluster. Okay, so my implementation is this one is let me see, it's 5. My filter is HR to by iPhone 4S is less than 60, and the working hour is 1,800. So that's my condition, but it will depend on different people, and it's very subjective. So yes, for part 6, so let's check using the data to obtain using HC solver and create a radar plot. Okay, and with JOX post radars, this radar plot, according to the PPT provided by Professor, I think we can have and also according to the code provided by Professor, I think we can using 2 types of plots. One is a very ugly one, just like this one, and another one we can using things like this normal plot, but we need to plot several radar plots together and then to try to find the cluster or the outliers. So, but for this, I think there's a shortcoming because every plot is too small. and it's very hard to find the clusters. And also, according here, some of them are trimmed. I mean the strings are trimmed, so we cannot find the letters. So it's better to handle this. But if we are using the normal reader plot, we can to write all the strings properly and can display all the things right. We need to draw big enough plot to show all the labels, which means we cannot draw too much reader plots in one row. So that will make a lot of them, and it will make it's hard to find the clusters. Okay, but it's much clearer than this ugly graphs, a star graph. Okay, then here we can see some cluster in this plot, like a cluster Tokyo, Zurich, Luxembourg, and outlines of Tokyo. But I have concern about this. How can we get from here? How can we get the outliers? It's very hard to see that. Let's check it one by one. Tokyo. Okay, but I think even if he write like this, he also should write some reason why it looks like this. Not just write 3 or 4 city names. And why it's outliers. Okay, then we go to part 7. Which of the two you have used in this assignment was the best, and why? From which perspective? This also right from the two used, the star reader plot is the most simplest and easiest. The reason is the reader plot have all the plot individually and plot and compare the shapes. And because this one is a very subjective, so I cannot comment on that. But my understanding or my point of view is I think the heat map is very easy to use, and the parallel ones is also easy to use, but because we cannot write show labels, so maybe it's kind of limitation, so we cannot say this, and even if we do this, we still need to check the origin data to find out the thing behind this plot. Okay, then that's the end of the assignment 1. Thank you.